Hi guys, we're going to take a look at a uniform motion type problem here. Not uniform motion, it's projectile motion, that's what I meant to say. In this case, we got after t seconds of height, h of t of a model rocket launched from the ground into the air is given by this function. H of t equals negative 16t squared plus 80t. The negative 16 is half of gravity, 32 feet per second squared, and the negative means it's acting downward, right, because gravity acts downward. And this 80, that's your initial velocity of this rocket, 80 feet per second in this case. T is time, h of t is height in a certain amount of time. We need to find out how long it takes a rocket to reach a height of 96 feet. So I've got a little diagram that I drew here. Our height is my vertical axis here, also known as the ordinate. My horizontal axis, also known as the abscissa, which you don't really need to know that part, is my time t. We want to find out when is it going to reach a height of 96 feet on the way up, and when will it reach a height of 96 feet on the way down. So basically, h of t is 96. So we're really solving this equation. 96 equals negative 16 t squared plus 80t. Well, we want to use the zero product property, which means we need to add 16t squared to both sides. And we want to subtract 80t to both sides. So we're looking at 16t squared minus 80t plus 96 equals 0. And that's the equation we're going to be solving, okay? Well, we're going to factor this thing, which means rule of the thumb, greatest common factor. I've got my notes here. Let's see if this thing is, greatest common factor is a 16, and it turns out it is. You can use a calculator or whatever if you struggle with these bigger numbers. But 16 goes into all these guys. It goes into 16, obviously, the one time, so we got 6 or t squared there. And then it goes into 85 times, so 5t. And it goes into 96, 6 times. So we're looking at 16 times the quantity of t squared minus 5t plus 6 equals 0. Let's divide by 16 to both sides, and I can ignore that once that happens because 16 divided by 16 is just 1. It's an understood one. Don't worry about it. So we're looking at t squared minus 5t plus 6 equals 0 divided by 16 is still 0. And the reason I can still ignore that is because I don't have a variable out here. If I had a variable with that 16, then I need to account for that variable. I don't. It's just the 16, so I'm good there. So let's go ahead and factor that. And I can factor this one actually pretty quickly. Okay? You trial and error on this. It's going to be t minus 3 and t minus 2, right? Negative 3 times a negative 2 is a positive 6. Negative 3 plus a negative 2 is a negative 5. So those are my factors, which means my time is going to be at 3 and 2. So 3 seconds and 2 seconds. Meaning, after 2 seconds, on the way up is when I'm at 96 feet. And at 3 seconds, on the way down, it's back at 96 feet. Okay? And that's how you take on these projectile motion problems. They're kind of fun. I use them all the time just for kicks. I've done a just for kicks type calculation where I had these kids one time that were ringing my doorbell when my wife was heavily pregnant with our second son, and they'd ring the doorbell and run off. And I was thinking, well, what if, I put a water balloon on top of the house, and when the doorbell rang, it would synchronize to the catapult, which would launch an air balloon that would hit the kids as they go running down the street. Did I put it into play? No, I didn't. It was just kind of fun to try that out. I also tried Barney the dinosaur problem where the Barney falls off a 400-foot building, and how long it would take Spider-Man to fling his web and reach Barney the dinosaur, and would he be able to do it in time before he hits the ground, and so on and so forth. All of which were fun. If you want to see how to do that, send me an email if you're one of my students, and I can show you all that stuff. I don't know if you're really interested in that or not, but either way, it's fun.